Stargazers, come up here, cause I have exciting news. Astronomers have just completed the full mapping of two pairs of stars outside our Milky Way galaxy that are chowing down on their stellar neighbors. Not only does it give us a better understanding of stars in general, but it can also help us measure distance in the night sky. Did you know that more than half of the stars in our Milky Way are paired? And while it's unlikely that other galaxies have a significant number of binary stars too, they're usually too faint to see. But these so-called symbiotic stars, where one star consumes the other, are extremely bright and easier to observe. And, according to scientists, measuring the orbits of these symbiotic star systems is an essential step towards learning whether other galaxies create binary stars like those in our Milky Way. Now, let's get down to the nitty-gritty. A pair of stars may be born together, but due to their masses, they age differently. The more massive one burns through its material faster, reaching the end of its lifetime first, and leaves behind a compact white dwarf. White dwarfs are small and dim, but can pack the mass of the Sun into an object the size of Earth. If close enough, their gravity can pull material from their companion, creating a signal that astronomers can identify from far away. Draco C1 and Lynn 358 are the symbiotic stars that have been fully mapped. The stars in Draco C1 take roughly 3 Earth years to orbit one another, while Lynn 358's components take just over 2. These are the first full orbital measurements of any symbiotic star system outside the Milky Way. The new measurements will help astronomers better understand star formations in other galaxies. In some symbiotic stars, the white dwarf can slurp enough material from its companion that it explodes in a supernova. These supernovae are incredibly bright and can be seen across the universe. They all start out with the same brightness for a nearby observer, making them like a sort of standard candle for measuring the universe. While Draco C1 and Lynn 358 are unlikely to explode as supernovae anytime soon, understanding how they work can provide us with a better understanding of how these standard candles evolve. If you're here to complete your knowledge of weird stars in the universe, don't be disappointed. We're not finished just yet. Have you ever wondered about the biggest stars in the universe? Scientists have recently discovered a gigantic star called UY Scuti. This bad boy is located about 9,500 light-years away from Earth and is truly out of this world. It's about 1,700 times larger than our Sun, which means if it were in our solar system, it would reach past Jupiter's orbit. There's more. UY Scuti isn't just massive, it's also super bright. It's what scientists call a red supergiant, and it shines with a brightness of about 340,000 times that of our Sun. If you're thinking about getting a tan from this star, think again though. It's way too far away for that. How does a star like UY Scuti even form, you might wonder? Well, it starts out like any other star. A cloud of gas and dust collapses under its gravity and starts to heat up. Eventually, the temperature becomes hot enough in the core of the cloud to ignite nuclear fusion, and a star is born. But UY Scuti didn't stop there. It kept devouring more and more gas and dust, growing larger and larger. This process continued until it became the giant we know today. As fascinating as UY Scuti is, it's not the only big star out there. There are others, like VY Canis Majoris, which was once thought to be the biggest star until UY Scuti stole the show. VY Canis Majoris is still a force to be reckoned with, though. It's about 1,400 times larger than our Sun, and located about 5,000 light-years away from us. But here's the kicker. Stars like UY Scuti and VY Canis Majoris aren't even the biggest things in the universe, not by a long shot. There are objects called hypergiants that make these stars look like ants in comparison. One such hypergiant is Stephenson 218, located about 20,000 light-years away. It's about 2,150 times larger than our Sun and shines with the brightness of 7 million suns. And just when you thought things couldn't get any crazier, there's a mysterious object called the Great Attractor that's pulling everything in our local group of galaxies towards it. We don't know what it is or what's causing it, but one theory is that it's a massive cluster of hypergiants. We'd be minuscule in comparison. The next star is so metal, it's practically headbanging all the time. Jokes aside, scientists have discovered a star that's called a heavy metal subdwarf. Now that's a band name. It's a type of star that's seriously heavy metal. This star has more metal in its composition than any other star we've seen before. Such stars are said to contain metal elements like iron, nickel, and chromium. This heavy metal subdwarf has about 10,000 times more iron than our Sun. In their discovery, astronomers used a technique called spectroscopy, which involves analyzing the light that comes from the star to determine what elements it's made of. By looking at the spectrum of light, scientists were able to see that this star had an unusual amount of metal in its composition. There's more. This heavy metal subdwarf isn't just a regular star with a lot of metal. It's also really weird in other ways. For one thing, it's smaller and cooler than our Sun. And for another, it's really old. We're talking about a star that's been around for almost as long as the universe itself. What does this all mean? Well, scientists are hoping that by studying this heavy metal subdwarf, they can learn more about the early universe. Since this star is so old that it was around when the universe was just beginning to form, it's seen a lot of stuff. By studying its composition and characteristics, scientists can get a better understanding of what the universe was like in its early days. This next star is one of the coolest things in outer space. Her name is Vega, and it's one of the brightest stars in the night sky. Some recognize it as the shiny point of light in the constellation Lyra. And get this, it's only about 25 light-years away from us, which in astronomical terms is practically next door. Scientists have been studying Vega for a long time, and they've learned some pretty interesting things. For starters, Vega is a young star, only a few 100 million years old. That might sound like a long time, but compared to our Sun, which is around 4.6 billion years old, Vega is practically a newborn. Vega is also a very hot star, with a surface temperature of around 17,000 degrees Fahrenheit. To put that into perspective, the surface of our Sun is only about 10,000 degrees Fahrenheit. So if you think it's hot outside today, just be glad you're not hanging out on Vega. Another interesting thing about this star is that it's surrounded by a disk of dust and gas. This disk is called a debris disk because it's made up of leftover material from when the star formed. Scientists think that this debris disk is similar to the one that surrounded our solar system when it was young. Vega is also a source of cosmic rays. These rays are high-energy particles that zip around space at incredible speeds. They're made up of protons, electrons, and other particles, and scientists aren't exactly sure where they come from. But they do know that Vega is one of the places where cosmic rays originate. But wait, there's more! Vega is also a famous star in pop culture. It's been used in a lot of movies and books as a source of inspiration, mostly because of its brightness and cool features.
What makes space so terrifying is its unpredictability. Even though 99.99% of the cosmos is a vacuum, if you encounter something of substance, the chances are high that it might easily end your life. And still, some things are scarier than others. For example, gamma-ray bursts. When a galaxy explodes, it releases a powerful burst of gamma rays, and those can completely annihilate any asteroid or planet in their path. A gamma-ray burst occurs in our home Milky Way galaxy once every 5 million years or so. Then there are vampire stars. Scientifically, they're known as O-type stars. Those are enormous blue giants attached to way smaller stars, which gradually get consumed by the gravitational pull of their huge neighbors. But vampire stars don't live long, happy lives. Once a space vampire has consumed a smaller star, it explodes into a supernova torn by its own gravity. Black holes are both endlessly intriguing and terrifying. They consume everything that comes too close and bend space-time around them. Can they get any scarier? Definitely, once we look at rogue black holes. One of them was discovered in 2016. This rogue black hole is heavier than the Sun and is moving at a speed of more than 1,240 miles per second. This black hole could have broken away after the collisions of its home galaxy with another one. At the moment, it's around 2 billion light-years away from us. Now, how about a mysterious space anomaly called the Great Attractor? This area lies around 150 to 250 million light-years away from our galaxy. The Great Attractor's gravitational pull is so powerful that it can move entire galaxies toward itself, making them collapse with one another. But the scariest thing? We still don't know what it is, and whether our galaxy will end up in its clutches one day. Meteors might not sound particularly exciting or scary, but they are some of the most realistic threats to our planet. Thousands of meteorites hit Earth every year. Luckily, most of them are too small to cause any serious harm. They either burn in the planet's atmosphere or crash into the ocean. Our own sun can be pretty scary too, especially when it produces powerful bursts of energy, solar flares. They often go hand in hand with coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. The next scary space phenomenon is the dark flow. All galaxies are supposed to be moving uniformly away from one another. But there's one large group of clusters that seems to be moving at a speed of 600 miles per second toward a small region of space between the constellations Centaurus and Vela. There seems to be no apparent cause for this, which is why this inexplicable phenomenon got its name. The cosmos also presents many dangers for astronauts. For example, extended space travel can apparently change human DNA. According to scientists, the stress from staying in space for too long might cause astronauts' cells to rewrite their genetic code. The worst thing is that such DNA changes are permanent.
To say space is harsh is, well, an understatement. It's filled with creepy things. What about gamma ray bursts that could cancel your existence, and mine too, on our planet tomorrow? Or mysterious, eerie, empty supervoids that are up to no good either? Which one scares you the most? Well, let's watch and pick, huh? And the first scary thing on our list is space junk. Look up there at the night sky. You might think you see stars and a few satellites, but there's something else up there, a mess of space junk, and it's growing. Earth's orbit is our highest trash dump. Old satellites that don't work anymore, empty rocket parts, and thousands of broken pieces are all flying around the planet. And they're moving insanely fast, so fast that even a tiny fragment can hit with the force of an explosion. Right now, we're tracking over 30,000 objects in orbit, and that's just the big stuff. There are millions more pieces too small to see, but still dangerous. In space, even something the size of a marble can cause serious damage. Still, extreme planets are even spookier. In our own neighborhood, some planets are kind of overwhelming. Mercury can reach about 800 degrees Fahrenheit. Venus is even hotter at 860 degrees, thanks to its thick, heat-trapping atmosphere. For reference, the Sun's surface is around 10,000 degrees Fahrenheit, but that's nothing compared to Kelt 9b, the hottest planet ever found. Its temperature soars to roughly 7,800 degrees. That's hot enough to rip atoms apart. Under conditions like that, Mercury would vaporize into glowing plasma. At the opposite end is a planet nicknamed Hoth. It's about 5.5 times Earth's mass and sits at around minus 370 degrees, just barely above absolute zero. Even though it orbits a star, that star is a dim red dwarf, so the planet gets almost no heat. Size-wise, Jupiter dominates our solar system. This gas giant outweighs all the other planets combined. But this planet, I'll let you read its name, is on another level. It's about 28 times Jupiter's mass, a big boy. It's so huge that scientists think it might actually be a brown dwarf, a failed star that almost ignited nuclear fusion. And then there's Venus, our solar system's climate nightmare. It's similar in size to Earth, but wrapped in crushing air that's nearly 1,000 times denser than ours. Winds there race at over 220 miles per hour. Sulfuric acid rains from the clouds, and the surface pressure would flatten you instantly. Sounds terrifying, but only until you hear about supernovae. A supernova is the most powerful explosion we've ever witnessed. It's what happens when a star ends its life in a massive, blinding blast that can briefly outshine an entire galaxy. So, what causes it? One type of supernova happens when a very large star, at least 5 times heavier than our Sun, runs out of fuel. While it's alive, the star stays stable because two forces are fighting against each other: gravity pulling inward and energy from nuclear reactions pushing outward. But once the fuel is gone, that outward pressure disappears. Gravity instantly takes over, and the star collapses in on itself in seconds. The collapse creates huge shock waves that blast the outer layers of the star into space. It's rather intense. But not as intense as colliding galaxies. You see, galaxies are bound by gravity and are constantly moving. That's why collisions are common, especially between large galaxies and their smaller companions. When a small galaxy drifts too close, the larger one's gravity ruthlessly pulls it apart, robbing it of its stars and gas and absorbing them completely. When galaxies of similar size collide, the outcome is even more destructive. Their spiral structures are torn apart, and neither galaxy keeps its original shape. Well, this sounds impressive, even by universal standards. And still, gamma-ray bursts are even more menacing. Those are the most powerful explosions in the universe. In just a fraction of a second, a menacing star many times heavier than our Sun collapses into a black hole. As it does, the star's outer layers are ripped away, and two narrow beams of energy blast out in opposite directions. These beams are so bright, we can detect them from billions of light-years away. In that minuscule instant, a gamma-ray burst releases more energy than the Sun will produce over its entire lifetime. It's not just a supernova, it's a supernova. Now, gamma-ray bursts are rare, but they're incredibly dangerous. Astronomers estimate their destructive effects could stretch across thousands of light-years. If one were to occur within about 5,000 to 8,000 light-years of Earth, the consequences would be catastrophic. One side of the planet would get flooded with deadly radiation. The ozone layer would be badly damaged or completely destroyed, leaving life exposed to intense radiation from space. The result would be a mass extinction, on the same scale as the asteroid that wiped out the dinosaurs. Now, we're approaching something even scarier. Something most of us are too afraid to imagine. I mean, other civilizations. What if they find us? There's something called the dark forest idea. Imagine the universe as a pitch-black forest. Everyone's hiding. If one civilization makes noise, another, far more advanced, might wipe it out instantly. Not out of cruelty, but out of fear. In a place this big, staying silent might be the safest move. Another alarming idea: what if a super advanced society wouldn't even see us as people? We'd be more like trees in a forest or fish in the ocean. Planets could just be raw materials, and life could be perceived as just a byproduct. There might even be civilizations so advanced they could use the energy of an entire star or even a whole galaxy. At that level, erasing a planet like Earth wouldn't take effort. Thinking about it is a little unsettling. Even more unsettling is considering the existence of supervoids. Those are some of the most mind-boggling structures in the universe. Imagine a patch of space so empty it's missing roughly 10,000 galaxies. It's cold, vast, and almost completely devoid of matter. A supervoid doesn't fit into our current models of the cosmos, and scientists often describe it with the word unthinkable. But it's not completely nothing. A few lonely galaxies drift inside, which is somehow even more sinister than total emptiness. The edges of the void aren't smooth. They have temperature shifts and subtle changes that hint at some invisible forces. Even light seems to get distorted there, making these regions super eerie. But the worst part is that some supervoids can impact us. For example, something strange is moving our galaxy through space at about 1.2 million miles per hour. In front of us, a massive cluster of galaxies, called the Shapley concentration, 650 million light-years away, is pulling us toward it. And behind us, scientists discovered a nearly empty region of space with almost no galaxies. They call this supervoid the dipole repeller, and it's shoving the Milky Way with incredible force. But it's probably better than being propelled toward a black hole. Black holes are some of the universe's most ruthless objects. They can swallow asteroids, comets, planets, and even stars. Almost every black hole starts its life as a massive star. Then it runs out of fuel, it collapses in on itself, and packs more mass into a tiny space than you can imagine. That's why its gravity is so insane even light can't escape. A lot of people picture black holes as giant cosmic vacuums, pulling up everything around them. But that's a myth. Black holes can only pull in stuff that gets super close, crossing what's called the event horizon, a point of no return. For a black hole with the mass of our Sun, that boundary is just about 2 miles across. And for a black hole as small as Earth, the event horizon would be just a couple of inches wide. Still, their gravity is powerful enough to influence stars and planets nearby. And now, we're finally ready to speak about the ultimate nightmare the human brain simply can't comprehend: the sheer size of the universe. Imagine this. You're sitting in your room. That room is inside your house. Your house is on Earth. Earth is part of our solar system, which has 8 planets. And that solar system is just one tiny neighborhood inside the Milky Way galaxy, home to at least 100 billion other planets. Now, it is getting wilder. The Milky Way is just one galaxy in a local group with few others. That group sits inside the Virgo supercluster, which contains hundreds of galaxies. And all of that is just a small part of the observable universe, which stretches about 93 billion light-years across. And that's only what we can see with our current tech. We have no idea how much bigger the universe actually is, or if it even has an end. Think about that. TRES-2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular, it's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists. But the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. We're used to thinking that asteroids are the only free-floating rocks in space, but things like OTS-44 make you think twice and shiver. Imagine a planet about 11 times more massive than Jupiter roaming in space without being bound to the orbit of any star. Given its gargantuan size and mass, if OTS-44 collides with any other planet, it would utterly destroy it and go on floating as if nothing happened. Scarier still, scientists are sure there are millions of such rogue planets out there, just waiting to be discovered. There's no hard proof of their existence yet, but theoretically, carbon planets have formed somewhere closer to the center of our galaxy. Any oxygen getting in their atmosphere would get into a reaction with carbon and transform into CO2, forming black toxic clouds. On the ground, there would be oceans made of tar, spewing up geysers of methane and crude oil. There would be rains too, but they'd be far from refreshing. Torrents of pure gasoline and hot liquid asphalt would blast the ground and probably burst into flames on impact. Hard to imagine anything that would survive such conditions.
In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact, if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the Moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the Moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our Sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, an active star-forming region. Look, how cool is that?
This is our home planet Earth and its satellite, the Moon. Zooming out, and here's our solar system. A bit more, the Milky Way galaxy. And we're a small dot among an infinite number of stars. Now, even farther out, a cluster of galaxies. Dots and swirls in the endless space. Further, there's Laniakea supercluster. That little dot here is our galaxy. Moving on, Hydra Centaurus supercluster. Huge clusters comprising thousands of galaxies are no more than a speck from here. Next, Pavo Indus supercluster. This is an area 200 million light-years wide. We can zoom out until we see the entire observable universe. Each little dot in here actually contains thousands of galaxies and quadrillion stars. Scientists speculate that our universe may look like a bubble, and that bubble might collide with another universe. Yes, other universes could exist. Actually, even a whole infinite number of those. All of them could have appeared after the Big Bang. The collision between them isn't impossible either. At least, it might have happened before. And the proof is here, in the direction of the constellation Eurydice. This place is called Eurydice Supervoid. It's about 1 billion light-years wide. By comparison, the width of our entire galaxy is only about 100,000 light-years. There's absolutely nothing in this place, and it may be a trace from an old collision between our universe and another. Scientists think they were passing by each other. When the distance between them was minimal, the gravitational forces of the bubbles began to pull toward each other, just like two drops of water trying to connect when they're close. But the speed of the universes was too high for them to continue interacting, so the other universe just tore out a piece of our bubble. There might have been about 10,000 galaxies in that void, and all of them were either destroyed or taken over by the other universe. Let's travel to the edge of our universe to see how this collision might have taken place. We're 10 billion light-years away from our home. Here, in another galaxy, we see amazing nebulae of different colors and shapes. And if you look in the other direction, there's a huge wall moving at us. All these bright sparks on it are enormous galaxies about to collide with us. But in fact, it's a humongous mirror that only reflects our universe. Here, space-time is distorted and begins to be pulled into another universe at a tremendous speed. The usual law of physics may simply stop working at this point. Gravity may disappear, and with it, all the stars would explode and people on the surface of planets would hang in weightlessness. But if the universes didn't go at a tangent but crashed directly into each other, things would be much scarier. The enormous amount of collision energy would probably cause an incredible explosion. Its force would simply destroy everything in our bubbles. Still, the two bubbles might begin to merge too. At first, all galaxies at the edge of the universes would be torn apart. But then, the merger would begin. The galaxies would start moving chaotically. They would fly past each other, break apart, collide, and explode. The collision of two galaxies is an accident of enormous proportions, and it might happen to our home quite soon, in space terms. The Andromeda Galaxy is heading our way. It's a spiral galaxy about twice the size of ours, and there are about 1 trillion stars there, which is twice more than in our Milky Way. At the very center of this bright galaxy lurks a dark beast, a black hole. Its weight is 2 and 8 zeros of the Sun's mass. Red giants hundreds of times larger than our Sun. Pulsars emitting enormous amount of energy like spotlights. Rogue stars, and many large and small black holes. This soup of dangerous objects is moving toward us at 68 miles per second. A trip to New York to Los Angeles at that speed would only take half a minute. The disk of Andromeda can already be seen with the unaided eye on moonless nights. As time goes on, it'll get even bigger. As Andromeda gets closer to us, its gravitational force will begin to stretch the arms of our spiral galaxy. It'll begin to unwind. The stars and planets will lose their orbits. One possible scenario is that an unknown asteroid, or even a dwarf planet from the Andromeda Galaxy, will crash into the Earth at an incredible speed. Our planet will explode just like a balloon from this impact. Oh, goody. Another option involves stellar collisions. Our Sun would face another star. The bigger star will slowly begin to consume the smaller one. First, it will steal the light upper layers from it, and then it will eat it just like spaghetti. Or even like rigatoni. When a large star reaches its critical weight, it will burst. This explosion will destroy everything around it, including our solar system. Perhaps the shockwave will even reach other neighboring stars. Yet another scenario is that our solar system will be thrown into dark space. Imagine a tennis ball tied to a rope. You take the rope and spin the ball over your head like a sling. Then you let go of the rope and send the ball flying. This is what will happen to the Sun and all the planets around it. We'll find ourselves in dark and cold space. But life on Earth will not be affected. We'll still have our bright star to keep us warm. The only disadvantage is that all the stars in our night sky will disappear. And the most likely possibility is that the merger of two giant galaxies will have no effect on us at all. The thing is, the distance between stars and planets in space is enormous, so they can all just mix together and form one giant cloud. It would be like shoveling fine sand through a big sieve. The objects won't interact with each other. But the most interesting thing will happen to the black holes in the centers of our galaxies. Right now, there's a dense cluster of stardust and stars around them. As Andromeda and the Milky Way come closer together, they will begin to dance with each other. Gee, will it be the twist or the foxtrot? And when the black holes get close together, they'll begin to swallow all matter around one another. Billions of tons of colored stardust, asteroids, and star particles will fly toward the very center of either black hole. It might seem like this process happens very slowly, but it's an illusion. Super heavy objects like black holes warp the space-time grid, so time is much slower near black holes. And all objects that seemingly stay on the event horizon for weeks or even months are actually long gone. When the black holes finally come together, they merge into one supergiant black hole, but its mass is slightly less than the combined mass of the two dark monsters. Some of their weight is transformed into collision energy. This energy is released so strongly that its waves can be felt in other galaxies. Now, a huge black hole gathers all this dense and hot core of the two galaxies around itself. At some point, the black hole feels full and throws out powerful jets of energy into space. This is called an active galactic nucleus. It's one of the brightest phenomena in the universe and the most powerful source of electromagnetic radiation ever known. These jets may be more than 5,000 light-years long. By comparison, the distance from Earth to the nearest star, Proxima Centauri, is only 4.2 light-years. And the explosion that accompanies the jets has the power of 100 supernova explosions. Wow, blows my mind. The blast wave from this event could even reach the edges of a new galaxy, and this outburst would be visible from millions of light-years away. Now, there are dense clouds of multicolored dust at the center of merged galaxies. The weight of these clouds is so great that they begin to shrink and take on a round shape. Gradually, they become so heavy that they compress the core and nuclear reactions start inside them. The temperature begins to rise, and soon, boom, there's a supernova. It's a veritable fireworks show at the center of the galaxies. Stars erupt from the fog and form new hot worlds. At this point, the arms of the two galaxies that were previously pulled out slowly return to their former shape. The super-heavy center of our galaxy has such a gravitational force that it affects stars and nebula hundreds of thousands of light-years away. The galaxy's arms twist again, and we see the new and finished galaxy, the Milkomeda, or Milkdromeda. Hey, how about the Milky Meter way? Blah blah blah. Well, that's hard to say. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX, and is currently playing tag with Apophis. With some luck, on the 2nd of April, 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. Osiris Apex will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. Osiris Apex has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare. You know, we've all begged for just 1 extra hour in the day. Actually, 2 hours would be better. Well, scientists have good news and bad news. The good news is that our planet is heading toward a future where a day could last 25 hours. The bad news is that eventually, the same physics that makes the day longer will also get rid of our planet's rotation, literally freezing Earth in time. Meaning endless days and nights and oceans fleeing to the poles, all while the atmosphere turns into a relentless planet-wide storm. Uh-oh. Now, back when the Earth was just a massive, messy cloud of dust and gas, gravity started pulling everything toward the center. As all that debris smashed together, it started to swirl, like water rushing down a drain, but on a cosmic scale. That spin caused a momentum. Since space is a vacuum, there was no air to slow us down. Earth just kept spinning, and that spin became a day. One full rotation takes about 24 hours, and that's the rhythm we've known since we started recording time. But the thing is, we adopted 24 hours as a close estimate. In truth, a day is never exactly 24 hours long. Now, basically, Earth keeps spinning, but it's constantly losing tiny bits of speed. That's mostly because mass keeps moving around. Think of it like a figure skater. If they pull their arms in, they speed up. If they put them out, they slow down. Earth does the same thing, except without arms. When the 2011 earthquake hit Japan, it shifted the ocean floor so violently that it pulled Earth's mass inward, instantly shorting our day by 1.8 microseconds. Conversely, as glaciers melt and water rushes from the poles to the equator, Earth's arms are spreading out, causing us to drag. We're not just sitting on a big rock. It's like we're on a wobbly spinning top that moves every time something heavy happens on it. Most days end up being a few milliseconds longer than 24 hours. We can't feel this, but atomic clocks can measure it. Over long periods of time, those milliseconds add up. And as they do, the length of a day slowly increases. That's how a 24-hour day starts drifting toward 25. To check this, scientists pulled together nearly 3,000 years of sky records. Thousands of years ago, people carefully recorded eclipses. It was a scary event. Kings, priests, and astronomers wrote the exact time and location when the sun vanished. Those records survived on clay tablets, scrolls, and manuscripts. For the sky to go dark, the sun, earth, and moon must line up perfectly. If the timing is off by even a second, the shadow falls on the wrong part of the world. Today, astronomers know the moon's movements with incredible precision. They actually bounce lasers off mirrors left on the lunar surface to measure its orbit. That's why, in theory, we should be able to rewind the past like in a YouTube video and see every ancient eclipse exactly where history records it. But when scientists tried that, the moon showed up too early, or too late. The shadow wasn't where the record said it should be. The puzzle only solves itself when you realize one thing: Earth used to be a little faster. When researchers adjust Earth's rotation to be slightly quicker, everything snaps into place. In other words, Earth was spinning a little faster in the past, and these eclipse records show it. On average, this translates to a day increasing by about 1 to 2 milliseconds every 100 years. That's 1,000th of a second. You'll never notice it. But over time, those tiny bits stack up. About a second every 10,000 years. That means we're roughly only 200 million years away from having that one additional hour of sleep. So the good news turns out to be only meaningful for future Earthlings. But why is this actually happening? Well, the answer is the moon. Its gravity grabs Earth's oceans and stretches them into huge tidal bulges. But because Earth spins much faster than the moon moves around us, those bulges don't sit neatly under the moon. they get dragged slightly ahead as the planet rotates. That means the oceans are constantly being dragged across the planet, rubbing against the seafloor and the continents. That rubbing creates friction, and friction is a thief. Where there's friction, there's heat. So the moon slowly turns Earth's spin into heat that spreads through the oceans and into space. And once that energy is gone, it's gone for good. Since there's no visible cosmic creature to push Earth back up to speed, day after day, the moon acts like a slow, steady brake, stretching our days little by little and drifting farther away as it does. Yes, as much as we used to fear that the moon would collide with Earth one day, it's actually going in the opposite direction. All that transfer of energy that's happening between Earth and the moon is slowly pushing our satellite further away, approximately 1.5 inches per year. We know this because during the Apollo missions, astronauts left mirrors on the moon's surface, and today scientists fire lasers at those mirrors and time how long it takes the light to come back. However, even though we are slowly pushing the moon away, don't panic. It's not packing its bags just yet. At the current rate, it would take tens of billions of years for the moon to retreat significantly. But it will stick around long enough to witness and maybe even cause the end of all ends, so to speak. The same braking force that is slowing us down now could eventually push Earth into a state called tidal locking. This has actually already happened to the moon. You know how we never see the dark side of the moon from Earth? Well, that's because Earth's gravity grabbed the moon eons ago and forced its rotation to stop relative to us. Well, if you give it enough time, the universe could return the favor. If Earth slows down enough to match its orbit around the Sun, the cycle of day and night will disappear. We could turn into what astronomers call an eyeball planet. Because the Sun would just hang motionless in the sky, the side facing it would turn into a blistering scorched desert. That's the pupil of the eye. The side facing away would freeze into a massive white shell of ice, the white of the eye. The only spot where life could hang on in this area is called the iris, a narrow strip caught between the crazy hot day and the frozen night. But even that wouldn't be a dream come true. You'd have super hot air on one side smashing into freezing air on the other. So this zone would be hit by insane hurricane-level winds whipping across the surface. Also, without Earth's spin shaping the oceans, water would slowly migrate away from the hot regions and collect in colder zones, reshaping coastlines and continents entirely. The planet wouldn't just have longer days. It wouldn't even look like Earth anymore. But here is the bright side. We will actually never see this happen, and neither will our descendants, at least not while watching from nearby. The math says it would take about 50 billion years for Earth to stop spinning and turn into that frozen eyeball fully. But our Sun doesn't have that kind of time. In about 5 billion years, the Sun will run out of fuel. It will expand into a red giant, swallowing the inner planets and likely vaporizing Earth entirely. Bye-bye! So, while Earth is slowing down, it will never actually get to zero. We won't end as a frozen, motionless rock. We'll end as we started, space dust. By the time Earth ever stops spinning, humans certainly won't be watching from the solar system. We might be scattered across the galaxy, living in space, or not even human anymore. Some of us could live inside massive structures built around stars, capturing their energy instead of orbiting them. Others might drift near black holes, using their gravity and energy in ways we barely understand today. Entire civilizations could exist as uploaded minds, connected through a galaxy-wide network, living in simulations instead of physical worlds. Well, wherever we are, Earth would just be an old planet concluding its story.